Uh, you may have noticed that some pins are labeled digital and others are labeled analog in on your red board. There are only 6 pins that function as analog inputs, and they're labeled A0 through A5. They're over here on your red board, it's A0 through A5. Those are analog inputs. They're expecting to get waveforms coming in, not ones and zeros coming in. They're not digital. Now, another term we need to know about in order to understand the circuit is something called a voltage divider. I made the mistake of saying to my electronics professor that isn't a potentiometer just a variable resistor? And he went ballistic on me. He said, no, it's a voltage divider. It just behaves like if it would be a variable resistor. But in reality, it's actually called a voltage divider. So a voltage divider is a simple circuit that turns some voltage into a smaller voltage using 2 resistors. The following is a schematic of a voltage divider circuit. Schematics are a universally agreed upon set of symbols that engineers use to represent electronic circuits. So here you have your voltage coming in. You have one resistor on this side. You have another resistor on this side, which is going to ground. And then in the middle, you have this voltage coming out. That's the middle pin of your potentiometer. But what changes inside a potentiometer is this: we can vary the resistance of these 2 resistors, and when we do that, different voltages will come out of V out. Potentiometer is a variable resistor that can be used to create an adjustable voltage divider. Okay, so you see this arrow here? That's called a cursor, and what that means is you have this resistor type thing that you can move the cursor up and down inside this variable resistor thing, and you're able to vary the amount of voltage coming out of the circuit, right? And so so this is, anytime you see a resistor kind of look to it that has an arrow next to it, that's not a resistor, that's a potentiometer. That's the symbol for a potentiometer. So this is a voltage divider that you can't change because there's no dial, there's no cursor. But as soon as you put a cursor on it or a dial on it, then you can vary this resistance on either side, and that's considered to be a potentiometer. Potentiometer is a variable resistor that can be used to create an adjustable voltage divider. Could you close the door, perhaps, so we can get interrupted again? Thank you. If the outside pins connect to a voltage source, one to ground and one V in is your voltage coming in, and the output at the middle pin will mimic the voltage divider. Okay, turn the trim pot all the way one direction and the voltage may be 0. Turn it the other side and the voltage approaches that of the input. It's not completely all the way up, but pretty much. A wiper in the middle position means the output voltage will be half the input. So if you see it right in the middle, you've divided the voltage in half. Exactly. Voltage dividers can be covered with more detail in the next circuit. But here's what it should look like. On one side, we label that as ground. It doesn't really matter which side you use for the voltage and the ground. And then the voltage coming out, the middle pin, is the one that we're going to measure in this circuit. So here's our circuit that I would like you to build either virtually, if you don't have a kit, or if you have a kit, actually build this. There's 2 parts to the circuit. It's kind of interesting. Basically, we're going to use this potentiometer to control how fast this light will blink. So we do our standard circuit for the LED. On one of the legs, we put a resistor, and that's going to pin 13. Okay, so pin 13 will either put out 5 volts or 0, and will turn on and off. So it'll just flash the light. And then on the other side, the short leg, that one goes to ground. Notice how the red power rail, the positive and negative power rails are connected to the 5 volts and the ground on the Arduino. So we're going to use the Arduino to power our circuit. Now, it seems like this is a separate complete circuit because you got this whole circuit and then you have this one that seems to be unrelated. The only thing different here is this one's, the one side is going to power, the other side is going to ground. It's that middle one that goes into the analog input, right? And so it's going to, we turn the dial, it's going to set out a certain voltage. It'll be a nice smooth change, right? not digital at all. And this is going to read that voltage. But then the question is, what is it going to do with it? Now, if you look at data sheets, you might see an Arduino kind of look like this. You know, a data sheet is very detailed information about electronic components, and certainly an Arduino is a complex electronic component. So each one of these has a meaning, and they're not really laid out like you'd see in the picture. Like say, you see here A0 through A5 is right there, but in actuality, A0 through A5 on the chip is right here. Now, what's interesting about the chip they use inside of the breadboard and also the Arduino Uno is it's made by a company named Atmel. My brother actually works at Atmel. He's in the accounting department there, so he helps make these actual chips that are used here in the Arduino. At least keeps track of all the numbers. So if you're more of a picture person, you can use this picture to create the circuit. If you're more of I like to paint by numbers type thing. My wife's actually doing a paint by numbers thing about the Eiffel Tower. But if you want to know where to plug things in, all the jumper wires, it tells you step by step where they need to go. And remember, each of the holes in the breadboard, at least in the middle part, has a letter and a number associated with it. So if you don't want to try to look at the picture and want to build it from this, then that's another way. If say your circuit isn't working, well, what you can do is you could look at the picture to see if it matches, but then double check it, this to see if all these connections are correct. And that helps you like troubleshoot when your circuit isn't working. Now in the table, polarized components are shown with a warning triangle and a whole row labeled in yellow. So a polarized component will only work in one direction. So an LED, if you get the positive and negative swap, say your LED is put in backwards, it's not going to light up. All the other components don't really care about which one's positive and which one's negative. The only one that does is the LED. So the next thing is we need to copy this code in after we build it. So I've actually built this circuit here. Here's the circuit, right? There's the potentiometer, and I got a light over here. But I need to get this code into the Arduino. I need to upload this code into the Arduino. So what I do is I say copy code, and then I'm going to actually load up my Arduino program. Now I'm running on a PC, so my Arduino program is a little bit different. It looks similar, but it's more native to the PC. It's not running out in the cloud or in a browser or anything like that. Okay, let me see if I can get it so I can see it. And I'll move it over here. Where'd it go? Oh boy. So here's the, I can actually get it to move. There it is. And it still has my binary counter out there. That's not the one I want. So I'm going to create a new one. And these programs are called sketches for some reason. They call them sketches. I said new. I don't want to open. I want to say new. Try this again. New. Oh, there it is. Okay, so I have a new setup here. All right. And so what I want to do is I want to go in here and copy this code. So I say, click on this and say copy. And that copies the code into your clipboard. And then in your IDE editor then, what you want to do is not just add it to the end, but you want to replace all the code that's in there. And so I'm cutting and pasting the code in. So we're going to take a quick read through this just to see how it works. Okay. Now I'm a software engineer, so I'm always a little bit more interested in software than I am in the hardware. But you know, there's other different types of engineers out there that might disagree. But I kind of like looking at how you program the Arduino to actually use the circuit that you built. First of all, we create a variable called pot position. So that's the position of the potentiometer, and that's an integer. And that's going to hold the value based on the position of the potentiometer. In the setup program, remember the setup program only happens once, or the setup function only gets called once in an Arduino program. And this is where you do all your initialization code. We're going to be using a new component in the circuit called a serial monitor. The serial monitor allows you to see the data going between the potentiometer and the Arduino. So we're going to initialize that and setting the baud rate to 9600. It has to be 9600 or it doesn't work. And then we want to show that the pin 13 we're using as an output pin, not an input pin. So that's the one that we have hitched to the light. So we're using that for output, right? Because we're turning the light on and off. So you just have to set up those two things. That's pretty straightforward. And then in our loop, this is the basically the loop part. It's not that complicated either, relatively short. First thing you do is you read the position of the potentiometer. So you do an analog read of A0. A0 is the port that the potentiometer's middle pin is plugged into. And it's going to read a raw voltage from there, from 0 to 5. But then what it does is it takes this analog read and converts it to a digital number. So over that range of 0 to 5 volts, it's going to superimpose a range of 0 to 1023. It seems rather arbitrary. Why 1023? Well, remember that computers are binary machines. We talked about that already. And because they're binary, they use base 2. And 1024 is a power of 2. 2 divides evenly into it. So, or yeah, you would say you could multiply 2 by itself a bunch of times, and one of those that come up is a 1024. And so we have 1024 different settings, but they're numbered from 0 to 1023. So you read that, and you're going to get back a number between 0 and 1023. It says that right here. So we want to print that out to the serial monitor. That'll allow us to actually see the numbers as it's really happening in real time. And then based upon that potentiometer position, we're going to use that to delay the light. We're going to turn the light on, set it to high, and then it's going to use that potentiometer position number that we got back to set how many milliseconds we wait before we shut it off. Okay, and then we wait again. And so we're going to have this blinking light that's going to be controlled, hopefully by the potentiometer, right? Because the potentiometer, as we turn it, this number, this pot position will change, and we'll get different numbers coming in to the analog port. And then we'll be able to change the rate in which the light blinks. So let's give this a try. So I'm going to plug this into my PC. And you can do the same thing certainly with your Arduino board with your Chromebook. Okay, so here I haven't loaded the program yet. I'm going to load the program. How do I do that? Well, remember, we're not using pin 0s and 1s on this one. Pin 0 and pin 1 on the right side of the red board. Remember, those were getting in the way. Every time we try to upload a new program, we'd have to unplug those. Well, we're not using those pins this time, so we don't have to do that. We want to verify that our program is correct, so we can click on this little checkbox, and I have to give it a name. So I'm going to call it potentiometer 2, maybe. That's its name. It compiles okay. Now I want to upload it to my Arduino. Now when I do that on a PC, you have to make sure you select the COM port correctly. I only have one to select, so that's COM3. And then I also have to make sure that the board is correct. It's the Arduino Uno board that we're using. Okay. You have to do something similar on the Chromebook. You have to choose the right board, and you also have to choose a port, which on the Chromebook it's like a USB port. It says USB on it. You want to select those, and once you have those selected, you should be able to upload the program to the Arduino. So let me do it. We see some lights flash, just telling you it's loading. And now the program is running. It says done uploading. See right there? Am I sharing my screen though? Is the question. I cannot tell. So I'm really having troubles with Zoom windows. They're just not cooperating today. I'm trying to resize the window, but it won't let me do it. Maybe like that. It looks like I'm sharing finally. All right. And so now the program should be running. If I turn the potentiometer now, I want to see. I'm going to stop sharing and then see if I can get my picture on the screen. Big sized. If I turn the potentiometer, see how the blink of the light is affected. So here's it all the way one way. And that must be reading 1023 because it's a really slow blink. How 1023 what? And the answer is, well, that's a millisecond. So it's a little bit over a second between when it turns it on and when it turns it off. And then if you turn it the other way, you'll see that the blinking light speeds up. There's also a light on the Arduino board itself that's connected to pin 13. So if you don't even have an LED and you want to try out some circuits, say your LEDs burn out, you can rely on the LED that's on the Arduino that's built in. Notice how they're blinking at the same rate. Now, if I turn it even more, it gets blinking relatively quickly. But then at some point, it turns off. And the question is, well, why is that? Here it's blinking really fast. I can kind of see it with the naked eye, but if I look at the video, you can't really tell it's blinking. Here you can tell. So there's a limit to what the eye can see, right? If it's blinking so fast that the eye can't even react to it, it looks like it's just on. Like you can get it to a spot where it just seems like it's on, but it's not on. It's just blinking really fast, so fast that you can't tell it's blinking that fast. Okay. And then it gets blinking so fast, you have no delay. You're just not giving it enough time for the light to even light up because you're shutting it off before it gets a chance to turn on. And so that's near the edge of the potentiometer, right? So, but say we wanted to see the raw numbers coming out of the potentiometer. Well, there's a way to do that. And you can do this on the Chromebook as well. There's something called the serial monitor. Now, I think on the Chromebook, it's near the bottom of the screen. For me, it's under my tools, I think. Serial monitor, see that? So you got to look around in your ID to see if you can turn this on. Because if you can turn it on, you'll see that it's sending out numbers. Like right now, it's sending out 139. So it takes that analog signal and converts into a number between 0 and 1023. And it uses that number for our delay between our blinks. So let me turn the LED and I want to see if this number changes. It does, it's going down. My blink rate is getting faster as my number gets lower. I'm at 64, go a little bit more. Now I'm at 32, turn it a little bit more. Now I'm at 12. It's blinking really fast. I can just barely see that it's blinking. Now, I'm trying to get it so it's just barely on. Yeah, 0. If you have 0, there's no delay between when it turns on and when it turns off. So it's not even going to turn on. But it looks like if you get to, trying to see what the lowest I can set it. So, yeah, it's like 1. 1 will keep it on just for a little bit of time. It's blinking so fast. You can't really see that it's blinking because it's so fast, but I think you're hitting a limit of some sort. Okay. Now, if I turn the potentiometer all the way the other way, my hope is that we get 1023. See, there it is. I've hit the top of the range. I've turned the potentiometer all the way to the right in my case. And I get 1023, and that gets used by the program as the delay between the blinks. And so it's a little over a second from when it turns on to when it turns off and then back on again. So by using this potentiometer, we're able to control the rate of blinking of the light. And we're using the potentiometer. And so you use potentiometers all the time. in a lot of stuff that you see. If you look, for example, I have a pair of speakers back there that I play music out of. There's 4 dials on that. One for volume, one for treble, one for bass, one to set up the Bluetooth. All of those are potentiometers, okay? So anytime you see a knob or a dial on something, it's hitched up to a potentiometer, and that potentiometer is doing a voltage divider, and they're reading that voltage, converting it to a digital signal perhaps, and then using that number to control the circuit, just like we're doing right now here. We've modeled that same kind of setup. So see if you can see the numbers going in. It's always kind of cool to see while a circuit is working exactly how it works and see what numbers it's actually getting. Instead of trying to imagine it, you can actually see that. Now there's also a serial monitor in the Tinkercad simulator. So if you want to also make the circuit in the Tinkercad simulator and see if you can turn the serial monitor on, you can do that as well. So that's what I'm hoping you'll do. Now this is an assignment. Let's go look and see what the assignment looks like. I'm going to share my screen again. We'll see if I can find that. Here I said link to the potentiometer assignment. What I want you to do is take a video of the working circuit. So you show the circuit with it kind of blinking, turn the potentiometer so I can see that it's changing the rate of blinking. That would be good. And then put that in a Google Slides presentation and then send that presentation to me. Can't spell today. Submit the web address, and then here's the actual assignment. I asked you to do that. Going back here, then let's finish up our discussion on this, on what we should see. You should see the LED blink faster or slower in accordance with the potentiometer. The delay between each flash will change based on the position of the knob. If it isn't working, make sure that you've assembled the circuit correctly and verify it and uploaded the code to your board, or you can see the troubleshooting section. We talked about the program. Here's the serial monitor. So looks like here, at least in this version of the IDE, this looks like the Mac version. Serial monitor has a little button up here in the top right corner. So if you want to see those numbers, you can do it that way. Here's a run of somebody doing that on a Mac, I guess. I pointed out the things in the code already, so we don't really need to talk about those. And then the coding challenges, if you want to try something to change it around a little bit, say you've got it working and you want to try something else, here's some other experiments you can do. You can try, hey, oh, is that my camera? Ooh, that's what I need, because I can't get this camera working. I've been trying to get my iPad camera to work, and it does not work. There's something wrong with the district. The way they've set up the iPads, so I have to. All right, cool. Thanks. I was going to ask you about that, so I'm glad it came. I got an overhead camera now, so I can take pictures and videos and stuff. So that'll be cool. All right. So you can change the range. Try multiplying, dividing, or adding to your sensor reading so that you can change the range of the delay of your code. So if you want to magnify that range, you could multiply it times 2. You take that raw number coming out, multiply it times 2, and now it's going to wait twice as long on one end. You can slow it down even further. Or you can try adding more LEDs. Add more LEDs to your circuit. Don't forget the current limiting resistor for each one. Remember, you want to put these in parallel. Try making LEDs blink at different rates by changing the range of each using multiplication or division. Boy, that would be really fancy. I wondered how you do that. You'd have to use different output ports. So you use pin 13, maybe pin 11, pin 12, and put each light on a different pin, and then read the same potentiometer, but then use a different equation for each light, and you'd get weird patterns of lights. If you want to try that. Now, if you have some troubles, the potentiometer is always reading 0 or 1023. Make sure that your 5-volt A0 and ground pins are properly connected to the 3 pins on your potentiometer. It's easy to misalign a wire with the actual trim pot pin. So make sure you take a look. You got to look underneath the potentiometer to see which which row the pin from the potentiometer is going into. If you don't see any numbers in the serial monitor, make sure you have the correct baud rate set, which is 9600. That's how fast it sends the bits across. Now, back when I was younger as a programmer, I had to create serial communication protocols just like this. But now we know what a potentiometer is. We know how to convert from an analog signal to a digital signal using an A to D converter. There's an A to D converter built right into your Arduino. It takes that analog signal and then converts it into a number that the user can, or that the computer then can use in its calculations to set, in our case, the speed of the blinking. All right, so that's all I have for today. You can work on this one, get it built, put the program in it, run it, take a video of it, and send that in as your assignment. And then tomorrow, we'll talk about another circuit. We're going to try to take everything we've learned in this first couple days on the Arduino and try to build a really cool circuit where we use our RGB LED, another LED, I think, potentiometer, and something called a photoresistor. I mean, I think maybe we'll do our photoresistor experiment tomorrow, and then we'll do that really fancy one perhaps on Monday next week. We have seniors in class. I'll try to figure out what the last project is for seniors this weekend. I haven't really nailed that down.